Man, it's crazy how time slips away. It was just 1:30, and I'm like, man, I'm gonna start lecture so early today. And I went and did one thing, and all of a sudden I'm starting lecture late. What's up, Zizao? Mothman's biggest fan. Nice to see a new name. You be Alex? Sluggo lovers, I'm so lost. Liam, do it small. Dusty Crop Hop, what's up? You be Marcos. JS, Mango Mutiny. Exactly, 116, let's go. I was gonna start the stream earlier, but as I just mentioned, that doesn't always happen. The what's up, P Spyman? So for 442 today, I'm actually not doing a lecture. I have a cop out of sending them to YouTube to watch someone else do the lecture. So I can actually stay longer after today, more than the 20 minutes. So if y'all want to have questions, you want to see examples, I have more time today after lecture. Have feedback about timeout on my lecture question? What might cause that? If you have a timeout on your lecture question, it's probably an infinite recursion. You're going infinite at some point. Is it really the only way you can time out? So, but I can answer more questions after. What's up, Bite? Yeah, maybe lecture question demo. I don't know. But let's get through these slides first. Let's do today's lecture. WebSockets. So we're still talking about event-based architectures and concurrency. We have multiple things happening at the same time. It's still the theme of this learning objective. And we're having each piece of code send messages to each other, and then each piece of code will react to those messages as the events for our event-based architecture. We saw sockets all last week, or we saw actors all last week, and they pass messages in the form of case objects and case classes. So this week we're going to shift gears a little bit and talk about WebSockets passing messages across the internet to be able to communicate with the good old internet, which we all know and enjoy. So the lecture question for today is to write a very simple WebSocket server. We're of course going to start out small, and no WebRTC yet. It's standard's still coming out. It's still in its infancy. WebSockets are more tried and true. So maybe someday, if 116 does WebRTC, I'm retaken. Yeah, maybe. So a very simple WebSocket server that's going to listen for messages of type increment with no data, so the equivalent of a case object, and keep track of the number of times that it's received a message of type increment, and then has a method that is not really part of the web server itself, but a regular old method. And when this method is called, it's going to return the number of times this server has received the increment message. So it's keeping track of just how many times it's received this message. And no testing for the remainder of these last three lecture questions, for the simple reason of WebSocket servers are pretty tricky to test. Writing the graders for these lecture questions and for the clicker, kind of tricky. I wouldn't put you through that torture. It's difficult. I don't have a good library. Maybe there's a library out there I'll use someday for this class, but with the setup I have right now, no, I'm not putting you through that. So we're going to start talking about this architecture, especially when we come back from break. I'll walk you through the pieces that we're not going to fill in this week, mainly MySQL. We're not going to talk about this until after break, and even then, we won't talk about it too much. No testing. So we want to talk about this architecture and how we can build what will eventually be what I'll eventually call an MMO when we come back from break and talk about it in a little more detail once we put all the pieces together. This week, we're learning about each piece individually. We started off with the actor system. We understand how that works, how we create a system, add actors to the system, and those actors communicate by passing messages to each other. We'll eventually have actors that communicate with the MySQL database, but today we want to talk about this WebSocket server. So we want a WebSocket server that's going to be able to communicate over WebSockets to either web front ends or desktop front ends. And today we'll talk about the server and web front ends. Wednesday we'll talk about desktop front ends, and we'll actually build one app with one server that is going to be able to allow web front ends and desktop front ends on the same app. So somebody playing, going to be a chat app. Somebody using that chat app on desktop and somebody using the chat app on the web is going to be able to. They're going to be able to talk to each other and communicate with each other. So let's talk about WebSocket servers. And before we do, let's talk about why we're even talking about WebSocket servers. So in 1.15, you already built a web server. So why are we even adding new technologies to this? So you built a web server. It was a chat app. We like chat apps because they're kind of simple. It's a simple proof of concept without getting bogged down with too many features and apps. But you built a chat app in 1.16. And to get new information from the server, you made AJAX requests. So the server was hosting data. When it was the chat app in the lecture example, somebody would submit data to the server. It would be added to the chat log, and then each client could request the entire chat log, get the new messages, and render them on the page. We did that through AJAX to get information from the server after the page loads, but the client had to ask for that information. The client had to say, "Hey server, give me the latest information." We did this through polling to kind of get a more lively app. We would have the server say at regular intervals, "Hey, give me the latest information. Hey, give me the latest information. Hey, give me the latest information." And we were able to get an app that worked. But if we had really time-sensitive information, we would really see the shortcomings of this. Say our polling is set at 1 second. Well, now every second you're going to get an update, but that means the information in that update might be as much as a second old. So we can decrease the polling time, but that's only going to get us so far because now we're sending a lot of requests. What if we want to get 10 updates per second? We're going to send 10 HTTP AJAX requests per second, and that's just going to be a lot of load on the server. You have 100 users, you have 1,000 requests per second. That server's going to start bogging down. You're going to start eating up bandwidth at that point. There's a solution called long polling. This is effective. It's trickier to set up, but it is quite effective. But we're just not going to talk about it because for no good reason other than it doesn't really have much to do with the concepts that I want to talk about. But we are going to talk about a newer solution, something more modern than long polling, which is WebSockets. So standardized in 2011. It's not that old of a standard, but it's old enough that it's reliable. And yeah, maybe someday we'll do WebRTC as that grows out of its infancy and gets to be a more mature standard. But in my opinion, at least, it's not quite there yet. Someday maybe. But even WebSockets, it took a while for WebSockets to be adopted. Now you can pretty reliably use them. Every browser has them implemented. We can use WebSockets these days. But it was fairly recent where before all the browsers had these implemented. So now we can use WebSockets. And the point of a WebSocket is to get this two-way communication between a server and client. So with HTTP, we can only have a request and a response. The client requests information from the server responds to that request. With WebSockets, we can have what's called server pushes, where the server can send data to a client unprompted. So once the server has an update, as soon as that server has an update, it's going to send that update to the client and to every client. So say you have 10 people connected to a chat app, one person sends a message to the server. As soon as the server receives that message, it's going to send that message to the other 9 clients. So immediately plus network delays, however long it takes to go through the network and for the server to process. That's how fast you're getting your message. You're not waiting till the next polling request. You're just getting that information right away. So that's what we want, especially when we do talk about an MMO. You want multiple players playing a game or having some online experience and interacting with each other in real time. If I move my character, I don't want you to have to wait a full second before you see that move on your end. Or what if you're playing like a first-person shooter and a player moves on their end, but you don't see them move until a full second later? We don't want that. We want something else. we're going to talk about WebSockets to solve that problem. Isn't it virtual assault to set unprompted updates? No, I mean, not if that's why you're using the app. If you're using an app to get the updates as soon as they come, and that's what you want, then that's what it should be. And you still have to, it's not completely unprompted, because the client does have to request the WebSocket connection. So it's not 100% unprompted. If you don't like that, block WebSocket connections. Don't tell your browser, hey, never send a WebSocket request. So to do this in our Scala code, we're going to use a library, Socket.io. This is this library adds features on top of the WebSocket standard. It does use the WebSocket standard, but it gives us a few extra features that are just quality of life features. One, it's going to maintain our connections. If our socket gets disconnected for any reason, Socket.io is going to reestablish the WebSocket connection for us. So we don't have to worry about actually maintaining that connection. Library just does it. You won't ever have to think about that. It's going to add message types. WebSockets do not have message types, but Socket.io does add this layer to the standard and creates a standard that looks like what we did with actors, which is the main reason why we were using this library. So now, instead of just sending data over the socket, we send data in the form of a message type, which may or may not have information attached to it. So we send a message type. If we just want to send a message, that's going to be like a case object. If we want to send the increment message, for example, for the lecture question, we just send, hey, here's a message of type increment with no data attached to it. That's like receiving a case object. And if we want to send a message with data attached to it, we're going to send a message type and also a string attached to it to give more like a case class, sending that over the socket. But each message is going to have a type, which is not going to be a Scala type. It's just going to be a string. So the type is always a string, and then that string, like for the lecture question, the string is the literal string increment. That's the message type. But there won't be any case classes or objects defined for these types. And then the socket is going to listen for messages of particular types, then run some code, whatever code we tell it to run, when it receives a message of that type. So since we have a new library, it's got to be in your POM. If you've been using the pom.xml from the examples repo all along, good news, you don't have to do anything. You've had this library all along. You could have been using it all semester, because it's always been downloaded via Maven. So let's take a look at our first WebSocket server. This is not the entire code. I don't want to throw all the code on one slide. We still have these classes that we have to define. But let's look at the setup for a WebSocket server, and then look at what those other classes are to be able to get all this functionality. So first, we want to import the library that we downloaded and get all the relevant classes that we need, all the classes that we're using in this code here that are not defined by us. So like connection listener, disconnection listener, message listener, stop listener, those are defined by us later in this same code. Everything else, Socket.io server configuration, connection listener and disconnection listener, which are connect and disconnect listener, not connection and disconnection listener, are different things. But connect listener and disconnect listener, those are from the library, and those are extended by these classes, in fact. But I'm getting ahead of myself. Let's just go through this one at a time. MaySolver did use Socket.io, yeah. So in the handout code, you didn't have to mess with it, but it does use Socket.io. So we import the library, all the code from the library that we're going to use. Next thing we're going to do is set up our configuration and tell it the host name and the port number that we want to run this server on. So for our purposes, we're going to listen on localhost, port 8080. So anything that wants to connect to the server is going to have to connect to our localhost port 8080 and connect to us. Or over the internet, this would still be the same even if somebody wants to connect over the internet. They'll just have to put our IP address in when they connect to us, or domain name if we get a domain name. So we're going to run our server. We're going to start our server. We created a configuration object. We're going to give that configuration to the socket server constructor to create a new server. And then we're eventually going to start that server and say, hey, start listening for connections. When somebody tries to connect on this configuration, make sure you accept that connection and start interacting with that client. And finally, we want this server to actually do something. So everything else is boilerplate. That's all set up. That's all basically cut and paste for each project each time you create a WebSocket server. This is the part that's going to change. What does this server actually do? So for this, we're going to use handlers. What's up, Trino? We're going to use handlers that defines what the server should do on different events. So those events can be messages that are sent to us, or as we can see, a connection. A new client has connected. What should we do when a new client connects? And what should we do when a new client disconnects? Yeah, I was playing with my settings. If all I did was change the settings in OBS. So if it's different, if it's better or worse. So the higher quality, I'm a little concerned if you don't have as powerful internet connection. If you don't have a lot of bandwidth. So if it's choppy for any of you with the changes, let me know and I'll put them back down. So for each of these listeners, so this code we saw on the previous slide, I'm going to start chopping up this program. These two lines here, all this other code is still there, but I'm not putting it all on the slide at the same time. So these two lines, I want to show what this connection listener and disconnection listener are doing and how we set those up. And we're going to bring back some polymorphism. We need polymorphism to be able to get these to work, because these have to be of type connect listener and disconnect listener, not to be confused with connection listener and disconnection listener. Admittedly, I should have named those a bit different than the library classes, but here we are. So these methods take objects of these types: connect listener and disconnect listener. Connect listener and disconnect listener don't do the things that we want them to do. We're going to have to extend those classes, override this onConnect and onDisconnect method, and give it the functionality that should occur on either a connection or disconnection. So when a new user connects, we want to add a connect listener, which is going to listen to the connect event. And when that connect event occurs, the server is going to tell any connect listeners, hey, somebody just connected, and it's going to do that by calling its onConnect method. So whenever a new user connects, we're going to end up calling this onConnect method and running whatever code is in here. Whenever a client disconnects, since we added this disconnect listener, we're going to run whatever code is in here. So we're getting the same idea as we did with actors and receiving messages of different types, but we have a little bit different setup. Instead of a more functional programming field, we're having more of a object-oriented feel to it. So it's kind of an object-oriented flavor. We need a connect listener, which defines the onConnect method. So we're going to create a new class that extends connect listener. So it is a connect listener, so we can give it here. Then create a new instance of that class, a new object of type connection listener, which is of type connect listener. Give it to the server as a connect listener, and then the server is going to call its onConnect whenever a client connects. No, it is right here. I do want to talk about it on this slide. And this onConnect and onDisconnect and the other message types that we're going to see, these all take a object of type socket IO client, but it gets a reference to the socket that connected or a reference to the socket that disconnected. And we usually want to store this. We want to store this reference somewhere in a data structure so we remember what clients are connected to us, and then we can send them messages later. If we want to send a message to this socket later on, we can look it up in the data structure, pull up that socket IO client, and then send it a message later on. So we usually want to store these in some form of data structure, especially like for the clicker assignment. We're going to have clients register their username, and we want to remember which socket is for which username and also which actor reference is going to be associated with them, because for clicker we're going to have an actor system and a WebSocket server all in the same program. Yeah, so a map of username to IDs, and it's up to you how you want to set it up, but you need that information associated with each other. Yeah, username to socket IDs would be a good way to do it. Do I make you do it on Wednesday? I don't think it's Wednesday, but Friday's lecture question, you will have to maintain that some data structure that's going to be able to do that. Yeah, pretty sure it's Friday with the DM server. So let's take a look at the other two listeners. We added 2 event listeners, and these ones have a little bit more syntax, depending on whether or not there's data attached to these message types or not. So what an event listener is going to say is when a message of this type is received. So like for your lecture question, you'll be doing add event listener of increment. When a message of this type is received with this class as its data that it's storing, tell this object that message was received, and that object will do what it needs to do, whatever it needs to do. Now, messages can be of 2 different types, at least that we'll do in this class. We could have different types here, but we're going to stick to these 2, keep things simpler. Can either be similar to a case object, where we have a message type with no information attached to it. And for that, we're just going to say class of nothing. There's no information attached to this message. We receive this message strictly to receive that message. For example, increment in the lecture question. You received a message of type increment. There's no information attached to that. You just got a message of type increment. For this example, you got a message of type stop server, which the server is going to send right before it shuts down to let all the clients know that it's shutting down. There's no information attached to that, so we say class of nothing. A chat message, so if we're building a chat app, which we're gonna, for a chat message, whenever the server receives a chat message from a client, we want to know the actual content of that message. So this chat message, a message of type chat message, is going to have the message itself as the data of this event that occurred, of this message that was received. So for that, we're going to say the data associated with this message is going to be a string. And we're going to say class of string, expect string information, string data, when you receive a message of type chat message. For each of these, we're going to create data listeners and give them this add event listener, the actual event listener that responds when messages of these types are received. Whenever, and each of these extends data listener, which takes a type parameter of the type of the data of that message. So this will always be, for our purposes at least, extends data listener of string or extends data listener of nothing, and those have to match whatever the class is that you have here. So since message listener is being used to react to chat messages of type string, it has to extend data listener of type string. So the JSON can be a string, P. So we're using strings, but those strings will often be JSON encoded strings. So with string, it is so versatile because a string can be JSON, it can be CSV, it can be whatever we want it to be. We can encode anything as a string. I shouldn't say anything, but most things as a string. You know what? I will say anything. You can encode anything as a string. Anything that can be stored in a hard drive can be represented as a string. I'll go that far. So message listener, because we can convert binary to strings. So message listener extends this data listener of string, saying I'm here, I exist to respond to messages whose content is a string. And whenever a message of whatever type, the listener itself doesn't actually know the type that it's responding to. But in this case, in this example, when a message of type chat message is received by this server, it's going to tell its message listener object, it's going to call its onData method rather. It's going to call the onData method with, again, the socket like we saw with connect and disconnect. But now we're also going to have the data associated with that. We're also going to have the data associated with that message. So we received a chat message containing the actual message that somebody typed into the chat. That message that they typed in the chat is going to appear right here. It's going to be in this data variable. Is it going to be a rewatch? I feel like I'm going pretty slow through it. But we got time to digest this anyway. So we get the socket that sent this message, the message that they actually sent, and finally an ACK request, which, hey, we're not going to use in CSE 116, so you can flat out ignore this. It does have to be there because it's part of the definition of the onData method that we're overriding. But we're not going to ever do anything with this ACK request. And this returns unit for what it's worth. So whenever we receive a message, this method is just going to print out that message to the screen. We receive this message from this client. And then send back a message of type ACK, just notifying, hey, I got your message, everything's good. So we're going to send something back to the client. Do I have that on another slide? Yeah, I do. So we're going to send something back to the client using this socket reference. So this is the first time we're going to use that reference to the client that sent this message and send it a message back. For that, we're going to use this send event method, which takes up to two parameters, two arguments. The first one is the type of the message you want to send. And the optional second one is the data associated with that message. So we're either going to use a second parameter, which is a string, and that will be the message attached to this message type. So in this case, we're effectively sending a case class, kind of similar to a case class in Actors, where we're sending a message of type ACK with this actual message. Or we can leave off the second argument and just send a message with a type without any extra information. Yeah, each socket is a person in the chat app, exactly. And in the stop listener, I forgot to mention that we replaced those strings, string, with nothing. So when we receive a message of type stop server, a client is saying, hey, server, stop. We're going to extend data listener of nothing, and the data is going to be of type nothing. And then, of course, we won't read data. There's nothing there to read. We just won't use that variable. But the variable still has to be there, again, because it's part of the header of this method. Actually, let me sit on this slide for a little bit longer. I forgot how sockets work. I mean, you came to the right place. This is an intro to sockets. But the server waits for... So you can build rooms. You can build like chat rooms and the clients join. It's whatever you want to do with the technology. But in a more generic sense, the server waits for socket connections. And then each time a client connects to the server, that server and client can have two-way communication back and forth. So maybe you want to build an app where the server treats each client as a separate entity and is only communicating with one client at a time and not sharing any information between clients. Or maybe you have, like what you're saying, all the clients connect, and what we'll actually see in my example, which I don't intend to show till next week, but maybe we'll... Actually, I think I might show it today anyway. Every client connects to the server, and each time somebody sends a message to the server will send using this send event, or what we'll see later is broadcast, which just sends a message to every connected client. Broadcast that message to every connected client. But if you want to build separate rooms, it's whatever you want to code after that. You can build whatever you want, like maybe a clicker game, where clicker actually does the first thing that I mentioned, where each client's connecting and the server is basically maintaining multiple one-on-one conversations. So how do we check if a message was received? So everything beyond what we showed, you can still use everything that you know about programming. So the server, the server is a class, so it can have state variables that can change. It can also be... Oh, yeah, this is a good question. This is something I wanted to mention. These classes that we're extending the data listeners, these are full classes. Whatever you can code in a class, you can put in these classes. You have to have the onData method. But beyond that, you can add whatever you want to it. So, for example, in the stop listener, we actually added a constructor parameter, which is something we're perfectly capable of doing. We added a constructor parameter, which takes a reference to a server, and then we actually passed in the server to this data listener. So this data listener actually has a reference to the server for which it's listening to messages, and now it can use that reference to talk to the server, to send it information, to tell it to do things. In this case, we're telling that server to stop. But if you had an extra variable, if you created a state variable in the server that says, say, number of times increment was received, then you can say server.increment plus equals 1 or something inside your listener. So your listener can have a reference to the server, which is a handy thing to have. If you have your data structures, for example, for Clicker, you have all your data structures that's maintaining all this information of usernames to socket IDs to reference actor references and everything. You have those data structures. To be able to access those data structures, it helps to have a reference to the server and then store those data structures in the server. Yeah, basically gave away today's lecture question. That's true, Spyman. But as long as you can turn that into code, I'm still happy. Okay, Socket.io does support polling as well, but we want it to be using sockets. Sometimes Socket.io reverts to polling unexpectedly. I've had really tough to debug bugs until I figured that out. My socket library was just using polling instead of sockets. So we set up these listeners to react to messages that the server receives. And we can use socket.sendEvent to send messages to the clients. So this is similar to, if you think the parallels from last week, you can think of socket as being sender. And you can think of these add event listeners as being cases in your receive method. So if this were an actor, we would say case chat message of type chat message, big arrow, this code right here. And then when I use socket, I would say sender exclamation point ack of I received message of data. Of course, that assumes you understand last week's content, which is pretty new, so you might not have a full grasp on that yet. All right, so let's take a look at a client. So we have a server, but a server's no good without a client. The server just sits there if it never receives a connection. So let's take a look at a client, and we're going to specifically build a web front-end client today. And then next week, oh no, get out of the way. And then Wednesday, we're going to see a desktop GUI. Let's move over here. So here's the HTML for our site that we're going to see. We could add CSS. We could, zhuzh this up a bit, but we're not gonna, because I want to focus on the technologies. So here's some just plain basic HTML for a web front end. And we're going to see the JavaScript. There is JavaScript for this as well. And we'll take a look at that in a few slides. But let's take a look at the HTML first, just to get this out of the way. So first, we're going to use a Socket.io library, but for front-end JavaScript. It's the same idea. It's going to conform to the Socket.io standard, so message types and keeping connections alive, good things like that. It's going to do the same thing for us. And spoilers, when we do a desktop GUI, we're also going to use a Socket.io library. It'll be a different Socket.io library, but we're going to use 3 different Socket.io libraries. One for JavaScript in the browser, one for GUIs in Scala for clients, and then one for the server. So 3 different libraries for that, all Socket.io. So we're going to import that. Same thing you did in 1.15. We're going to add the script tag and give the URL for the library that we want to use. Next, we're going to set up our quick chat message, which shouldn't say gold, but it's a copy-paste error from the clicker assignment. You can tell I reused some of my own code here. And we're going to have a button that's going to call this send message function, which is going to be defined in our JavaScript. And finally, our JavaScript, we're going to import this. And then this webclient.js, that's where we're going to implement send message and set up the socket connections. So let's talk about the good stuff, that webclient.js. So in JavaScript, in our webclient.js, that's this file, we want to first connect to the server. We're going to run this on the same machine that we're running the server. We're just using localhost for now, not deploying on the internet. So localhost 8080. That's where our WebSocket is. Our server is already running and listening for the connections. And I'm going to specify that this one always gets me, but that the WebSocket library should use WebSockets. As P pointed out in the chat, WebSocket.io will sometimes use long polling. It'll sometimes revert to long polling unexpectedly. At least it was unexpected to me when it did that to me before. But if you specify, hey, it's WebSockets or nothing, using this transports, you'll make sure that it either uses WebSockets, or if WebSockets aren't working, it'll just crash. It won't revert to long polling. And then you won't have to go through that long debug process that I went through trying to figure out why, anyway. And to specify how our client is going to react to messages, we're going to use the socket.on method. So the socket reference for our connection, this is we can think of this as a reference to the server. And we're going to say on. So on messages of type ACK, call this function. We're using first order functions in JavaScript now. So in case you weren't ready for that one, surprise. So socket.on, so when I receive a message of type ACK from the server, call this function, this anonymous first order function, after that event occurs or after this message is received. The content of that message will be in this event variable. So if we don't expect any information, that we just won't use that variable because it won't have any information. But if we do expect something, we can use that event variable. In this case, we expect event to say, I received your message of, of whatever message we sent. And we're going to display that on the website. If we receive a message of type server stopped, which we don't expect any information to be to occur there, we're just going to edit some HTML and display something to the screen, some message to the user. But the important part, on some message type, call this function. So this is code that's running conditionally each time we receive a message of that particular type. To send a message, oops, got ahead of my slide. And where again, ACK, we expect information in event. We expect it to be a string. Just for this class, we're only going to use strings. So that's similar to a case class. And this is similar to a case object. Server stopped, we don't expect any information attached to it. So it's kind of like receiving a case object. It's unsafe practice to use inner HTML. Is it unsafe or just not good practice? It's not the best practice, but I'm not aware of it being unsafe. As long as we're escaping our HTML. Yeah, it could be HTML injection if I'm not escaping my HTML in event. So that's something we have to be aware of. Yeah, bad practice? Yeah, maybe. But I'll give you bad practice. But it's simple. I can show it off in lecture examples, and it works nice. So to send a message to the server, we're going to use this socket.emit. And it's the same syntax as we saw with send message, where it's the message type, then the message itself, or just the message type if it's similar to a case object where we have no information attached to it. Are there missing parentheses? There might be. I don't see any missing. I mean, this code runs, so of course JavaScript is pretty lenient with that. I don't see any missing parens. The on function? No. Like this open paren is closed down here, which can be trippy to see. This open brace is closed down here. That can be trippy to look at if you haven't seen syntax like this before. But it looks like everything's balanced. Cool. And let's see this thing in action. I can go back to my rightful home. All right, so here's our code that we just saw in lecture, all in one place. We have our listeners that we're adding, setting up the server, and then each listener defined in this same file. We could put these in separate files if you want one class per file. That'd be fine too. I put them all in one file because it's easier to show you all the stuff real quick. Jesse, just fly through the screen. I could try. Oh, because I moved my face. Oh, yep, that ain't gonna work. So if you see, oh, I'm glad I did this because I can tell you what this is all about. If you ever see this message, address already in use, it means somebody's already using the address, and almost always you're going to be the culprit. You're the one using that port. You're not going to have other software that's using that port 8080. And my problem was I had another server running. I had the chat app already running for Wednesday's lecture, which I was actually using for 199 videos. So since that was already listening on port 8080, I tried to run another server also listening on port 8080, and it says, no, you can't do that. You can only have one process listening to a port at a time. Mailsolver extensions I will get out tonight. I got a lot of submissions to look through though to make some judgment calls. So now that we have this server running, I'm going to open up a very simple there it is. Very simple client not like that. So let's go through the code first. Very simple client that we saw, which I did update a little bit. That is called button, rightfully so, instead of gold. But looks like everything else should be exactly as we saw in the slides. And when I send a message, the client, the server responds with that message that it's supposed to respond with. And if I look at I'm looking at the wrong buttons. And if we look at the server, we can see that we have a client that connected, and we get the reference for that client. And we also see the message that we received, and we can match the references. And if we store this reference, this is going to be the same every time we interact with this client. We get that message, everything's checking out with that. And I think I don't have anything else to show with this demo. I'm more interested in the chat app, I guess. But I guess we could do it manually. So let's send a message of type stop server, just so we can see that side of it as well. The server has stopped. If we go to IntelliJ, we expect that server to in fact be stopped. So stopping server. So we called this code here. And I did add this. So there's a little bit different from the slides. This is going to send that event to every client who's connected to this server, print to the screen, and then actually stop the server. So now when I go back to my web client, I can send messages, I can try to send more stuff. I'm never going to get another response because that server is stopped. Hacking my own server. Yeah. It's not always a good sign. I shouldn't have to hack my own server. I should just have every part of the example ready, but hacking works too. So let's restart this and show off, since we're here, we came this far, let's show off that broadcast operation. So if I have multiple people connected to this isn't actually a chat app, so there's no interaction. We'll see that later in the week. I typed the exact same thing both times. But if I go over here and I do stop server again, since that is broadcasted to everybody, everyone gets the stop server has stopped message. Because I use this broadcast operations. So I accessed the server, said get your broadcast operations, and then send event with the same syntax. This is similar to a case object. It's a message type with no data attached to it. So I'm just going to send the server stopped message to everybody through that server. And this is another case where having a reference to the server is very handy. So I can send that event. And there's one more thing. Yeah, because I used this one before. If you run this GUI client, this is going to be a desktop app. That's going to do the same thing. So let me restart the server. Oops, don't stop the client. Actually, I might have to, right? Because the server wasn't running. And here, I just restarted that server, and we can see we have 2 connections. That's the Socket.io library reestablishing those connections for me. Handy. Yeah, you only have to make the server for the lecture question. So, and that's what I'm showing you right now. So this client, which is in the repo, which is this GUI client. If you run this goes along with the server that we saw today. We'll see how to build this on Wednesday. I just resize this. And this is going to do the same thing that the web version does. This is where I have the rest of it set up. But it also has this extra button, the stop server, so I don't have to hack my own stuff, my own code. And it has this handy increment button. Guess what the increment button does? It sends a message of type increment to your server. So if you want to test your socket server, once you have it running, once you have that server running for today's lecture question, run this GUI, click increment a few times, and then make sure it does what you expect it to do. Maybe after each time increment is sent to the server, maybe have it print out its current value of increment, or call the get increment value, whatever it is in the lecture question method. I can look that up. So maybe call this number of messages method every time you receive a message of type increment, just to make sure everything's working right, since you don't really have a better way of testing your stuff. Do the code have to be in the same project? Nope. Since you're using networking, they don't. As long as the server's running anywhere on your machine through any means, it's going to have localhost port 8080 locked up. So you run a client anywhere, it's going to connect to port 8080 and be able to communicate with that server. So for example, I ran that server in IntelliJ, and then I ran the front end in my browser. They're able to communicate because they're using networking technologies. Lecture question demo walkthrough, let's go. I mean, I basically already did the demo. Basically gave you every piece of that lecture question already. All right, that's officially the end of the lecture. Speedrun Maze Solver. See you Wednesday, Mango. Mute any. Speedrun Maze Solver. No, I can't speedrun Maze Solver because the extensions are going to go out. People will still be working on it. Yeah, no 442. I have to make a slide or something in, so we can be chatting in 442 and though. I'm going to just do this. Sure, that should work. Who wants to talk about Clicker? Ooh, yeah. Look at all that code compiled. Speedrunner with A star. We don't need no A star. We can do breadth first search. Works just fine. Man, I can afford a lot of these. Which GUI client did you run? Good question. Let me find where I am again. GUI client. Oh, there's a couple called GUI client. So week 11 WebSocket Client, GUI client. I have a few called GUI client. So Clicker. If you want an example of Clicker working, just head to this URL. You can verify that you understand the requirements. You can run this configuration file, this code configuration file that's given in the repo, and you should expect all the behavior that you see here. And if you go to this and choose, some different username, test. Oh, I don't have that link to the enter button. You'll get a fresh start, and if you enter a username that you've already used, you can resume your game. So I have autosave implemented in this server. So I have the expansion objective. So for a Clicker, you click the big button, mining gold or compiling code, whatever the application may be, and you get code. I'm going to submit to Autolab. I'm going to buy one of these, which increments my income per click by 1. So now each time I click, I'm going to get 2 units of code compiled, whatever our units are. Once I get up to 100, I can buy a print statement, which is going to help me code faster, help me debug faster. And we'll get up to a unit test so I can talk about income per second and idle income. Oh, I can't do that. Alright, we'll do this. I'm on the wrong window. Damn it. I had it all set up too. Ooh. Alright. So I can buy a unit test. This has 50 income per second. So every second, I'm going to expect 50 income. It's not going to go in increments of 50. This is a common mistake I see. This can work with partial seconds. So this is updating at 10 updates per second. So that's why we can see this going up by 5s. Every 10th of a second, we're getting 5 income from that 1 unit test that we just bought. So this has to work with partial seconds, and it has to work with partial values here. If we get half of a code compiled after 1 update, then this should be, this should reflect that. It should have that 0.5. Here I'm only displaying whole numbers. I'm not displaying the fractions, but there are decimal portions here. Which, do I actually have that? I might. Where am I looking? Yeah. That doesn't update though. Oops. Yeah, there we go. So this does actually have a decimal portion. So in your code, you need that decimal portion, even though in my GUI it's not displayed. Just because I think it looks gross on the GUI. I've seen that mistake so many times. I'm sick of seeing it, so don't make that mistake. Why can't I buy a debugger? You poor bud. Need some cash. Once you start getting debuggers, as it should be, you start getting a lot of code compiled. Oh, you're right. Why can't I buy a debugger? Oh, because I have 10,000, not 100,000. I need 100,000. What is the best way to get up to a debugger? Forget how I got there before. Clicking is definitely the fastest thing to do still. Ooh. Can't keep doing that. I know. Just playing my own game. I should build out this game a bit more because, I don't know, I get sucked into clicker and idle games. Yeah, I've auto-clicked my own game before, but I made the mistake of showing that on stream once, and then the server crashed because everybody did the same thing. Yeah, Dennis Grace. So you can... I updated all the homework deadlines to be the homework expansion deadline. Or the last day to submit dates, anyway. So if you want to do a homework that you didn't do when it was due, you can go back and do those for the expansion objectives. So if you didn't do calculator and you didn't get an extension or anything, you can still do calculator for an expansion objective. Or maybe you were on the line of getting an extension and you didn't get the extension or something. You can still finish that for credit for an expansion. But you can only do that twice. How can I save this game? It auto-saves. So if I go back and I type in test again, I'm right where I left off. Auto-save, as all things should. First time watching a person play a game on Twitch. I'm happy to be your first. Oh, wow, I blew through my debugger. Not disappointed. Yeah. Except I'm already at endgame. I already got the most expensive piece of equipment. $13 debuggers. Oh yeah, I forgot I did this one. This one I needed an auto clicker for to get 16 submissions to Autolab and nothing else. I forgot I already showed my big one, didn't I? Once you buy a bunch of debuggers and let it go overnight, you get ridiculous income. Except my debuggers are so expensive now, I can't really do much. I shouldn't have showed this. So with no 442 lecture, we have all this time to chat and do examples and stuff. And instead I give you a clicker game and now everybody's playing. I didn't mean to distract you all. Let me go back. I'm sure I missed some messages up here. G83 just watched the Cookie Clicker lecture in 199. I'm happy about the way the lectures I released last night. I'm happy with the way they came out. I mean, there are always things I would improve, but I think they're fun. An extra homework counts as... Wait, an extra homework counts as 2 expansions, right? No, an extra homework would count as 1. If you did 2 extra homeworks, it would count as 2, but each one only counts as 1. Unless you do an extra homework and its expansion objective, you can do just 1 extra homework and have it count as both expansions. But either doing extra homeworks or expansion objectives, each one counts as an expansion objective, and you can get credit for up to 2 of those things. So you have a lot of flexibility in what you do for the expansion objectives. So if I did rhyming dictionary, the physics engine would count as an expansion objective, and its expansion would also count as an expansion objective. Yes. I was always a little confused on that. Yeah, so if you did rhyming dictionary, and then you do physics engine and its expansion, that's 2 expansion objectives, and you're done with expansion objectives. There's no main method in GUI client to run it. I might have... Oops. I got too many things now. Window... No. Goes right there. GUI client doesn't have a main. It probably extends... Yeah, it extends JFX app. So if you run this object, or if you right-click, and oh, you can't see the pop-ups, but if you right-click over here and then choose run, it'll work too. But JFX app, I think I got burned last time I tried this, but this should have a main method in it. Yeah, this is where the main method is. So we inherit that main method from the JFX app class that we're extending. Well, the 442 note takes up a lot of that, doesn't it? Let's get this a little smaller. But you did see, you were able to see that, right? Yeah, that wasn't obscured.